Hello students, this is the section the least squares regression line, which is a continuation from the previous section correlation. This is from chapter summarizing bivariate data. The objectives for this video are to be able to compute the least squares regression line, to use the least squares regression line to make predictions. We're going to practice interpreting predicted values, the slope and the y-intercept for this regression line. I want you to first take a look at the least squares regression line equation. It's of the form y equals b sub 0 plus b sub 1 x. This is given a set of order pairs, which we're going to call the variables x and y. We have to compute the sample means for both the x values and the y values. We have to compute the sample standard deviations for both the x values and the y values. And from the previous section that we learned how to compute the correlation coefficient R. Our equation will be of the form y equals mx plus b, if you remember from high school or your algebra or college algebra courses if you took them. Our b sub 0 will be the equivalent of your b in the form y equals mx plus b, which is the y-intercept. And b sub 1 will be our slope, which you previously used the letter m to represent. To calculate b sub 1, you need your correlation coefficient and both of your standard deviations. To calculate your slope, you're going to multiply the correlation coefficient times the standard deviation of the y values divided by the standard deviation of the x values. And to compute your y-intercept b sub 0, you're going to take the mean of the y values and subtract your slope that you computed times the mean of the x values. I'm going to show you using the same example from our correlation section, the one that involves the price of the gallon of milk and the dozen eggs. But first, let's introduce a little bit of vocabulary. We're going to be referring to our x variable as the explanatory variable or predictor variable, and we're going to be referring to our y value as our responsible variable or outcome variable. From the previous example, let's recap what we did in the last section. We took the average price in dollars for a dozen of eggs and a gallon of milk for the 12 months of a recent year. These were the prices. And we constructed a scatter plot. We plotted each of those prices of eggs in relation with the prices of the gallon of milk. We had that it was a positive linear association, and we computed the correlation coefficient. Before we start computing our least squares regression line, we needed to find the correlation coefficient, for which we needed to find the standard deviation for both the x and the y and the means for both the x and the y. By hand, if we have computed it by hand, we would have to add all of the values of the prices of the eggs and divide by the count, which was 12 months. And add all the values of the prices of the milk and divide by 12, which was our months, to find the mean for the milk. I showed you how to do this in Excel. We are going to be using the command equals average, like this, with an open parenthesis, and we're going to select our data that we want to compute the mean for. Because I'm looking for the mean of the x first, I'm going to select the data of the eggs. It looks like our mean is 1.8375. For the mean of the milk prices or milk of the mean of the y's, I'm going to do the exact same thing. I'm going to use the command average, open parentheses, select my data, hit enter. If we wanted to compute the standard deviation, our formula was the sum of the deviation squared divided by the count. The count minus 1 if it was a sample standard deviation, which is the case in this example, and then take the square root. Lucky you, in the previous videos, I showed you how to do the standard deviation using the command equals stdev, point P for population, point S for sample. Because we're looking for the standard deviation of the sample, I'm going to be using the command equals stdev points S right here, this one. stdev point S. For the X values, enter, and then I'm going to repeat the steps to find the standard deviation of the milk or Y values. stdev point sample, open parentheses, select the values of the milk. From our previous video, I show you how to find the correlation coefficient also in Excel. You're going to use the command equal correl for correlation, open parentheses. I'm going to select both the X value columns and the Y value columns, starting with the X value columns. In order to be able to select the next one, I have to put the comma, and then now I select my Y values, hit enter. That's my correlation coefficient. So that's how I got my standard deviation for both the X and the Y. And then this was the formula for the correlation coefficient from the previous section. If you wanted to see it in, like, after we substituted, after you did everything, these are the steps we followed. We created a table, we computed the subtraction of X minus the mean divided by the standard deviation for all of the X values. Then we repeated the same steps for the Y values, and then we multiplied these, add them all up, divide by the count of values, which was 12 minus 1. And that's how we calculated our correlation coefficient, by using this formula. Now, we need all of these values to create our regression line, our least squares regression line. What is a regression line? Taking into consideration the scatter plot that we created of the prices of eggs versus the prices of milk, that's the line we're going to be using to make predictions of values we don't have the data for. Here's another representation of the regression line with our data a little bit more scattered. Now, again, we computed all those values using Excel. We're going to use those to find the slope and the y-intercept for our least squares regression line. Remember, the formula for the slope was b sub 1 equals r times s sub y divided by s sub x. I hope you remember what these values represent, but this b sub 1 will be the symbol we were going to be using for slope. S sub y was the standard deviation for the y values. S sub x is the standard deviation of the x values, and r was our correlation coefficients. So I'm just going to take those values and substitute them. I'm going to take my standard deviation for the x values, my standard deviation for the y values, and my correlation coefficient. I get that the slope is b sub 1 equals 0.399065. Similarly, if I wanted to compute my y-intercept, I'm going to use the formula b sub 0 equals the mean for the y values minus the slope that we just computed times the mean of the x values. Our slope was 0.3990. That's what I'm going to substitute here. This is b sub 1. I take my mean for the x and for the y values and substitute. This will be my y-intercept, 2.7592. Now, those are the values we're going to substitute in our least squares regression line equation. B sub 1 is going to be 0.3990, and B sub 0, your y-intercept, will be 2.7592. We usually round the slope and the y-intercept values to 4 decimal places. If your assignment asks you to round to a different decimal place, please follow the instructions in your assignments. Here we're going to be using our least squares regression line to predict the outcome variables using our explanatory variables. Important. We're not going to round the value of R if we're computing it by hand until the very end. You want to keep as many decimal numbers as you can while you're in the process of computing your correlation coefficient. And please do not confuse whatever your value of slope is, b sub 1, for your correlation coefficient. They're not the same value. Now, using this least squares regression line, we can predict values. Let's attempt to use our least squares regression line to predict the selling price of a gallon of milk when the X is $2.50. All we have to do is substitute that $2.50 in our X value, compute it, and we're gonna get the price of a gallon of milk when the price of the dozen of X is $2.50. Approximately 3.76 cents. Now, remember, correlation is not the same as causation. It doesn't mean that if you change the price of the gallon of milk, the price of the eggs is going to change, or backwards. If the price of a dozen of eggs changes, the price of the gallon of milk will change. Let's go over another example. We're going to use the least squares regression line to predict the selling price of a gallon of milk when the X is 3.77. Do not penalize me for this. This was taken a while ago. I know the price of a dozen of eggs is more expensive now. But let's take it as $3.77 from Walmart. Then I'm going to substitute that 3.77 in my X value. And according to my least squares regression line, the price of a gallon of milk should be 4.26. At that time, I checked it and it wasn't 4.26. It was actually cheaper. It was 3.70. So it's just an estimate. Remember, correlation is not the same as causation. And we always have to take into consideration our data range, which takes us to the next portion of this video, when we want to interpret the y-intercept and the slope for your function. The point where your least squares regression line crosses the y-axis, it's the y-intercept. And this only applies when you have 0 as part of your data range, or when you have positive and negative values for your explanatory variable, meaning that you have both positive x values and negative x values. If your values are outside of your range of the range of your data, we do not interpret those. For example, if we're talking about the horsepower versus the miles per gallon, there's no such thing as a car having 0 horsepower. That's not part of our range. So our y-intercept cannot be used to interpret values for 0. Okay, now we're interpreting the slope. If you have two values that differ by 1, then the y values for those particular two values is going to differ by the slope of the line. If you have two values of your explanatory variable x differing by any number, to find the difference of the y values for those x values, for those respective x values, is going to be the slope times the number, times the difference. Let's apply this when we're trying to calculate the difference in price of milk in relation with the difference of price of eggs. Let's suppose you have 2 dozen eggs for different brands. One costs 3.77 and the other one costs 4.72. We first calculate the difference between the two. 4.72 minus 3.77 is 0.95. I'm going to multiply that 0.95 times my slope to get the difference between the two brands of gallon, the two prices of the different brands of milk. So for those, using those values of the brands of the dozen eggs, we can predict that the difference in the milk is going to be 38 cents. Only by multiplying the difference from the eggs values times the slope. Now going back, if you want to use Excel to calculate your slope and your y, your b sub 1 and your b sub 0 for your least squares regression line, you can. The commands will be slope and intercept. That's how you can find both. So if I want to find b sub 1, which is my slope, this will be equals slope. I click on the command or just type it and then open the parentheses. Notice how it says I have to select the y values first and then the x values. I will do so. I will select first the value of the milk, comma, then the value of the eggs. First the y's, then the eggs. My slope will be 0.3990, and for my y-intercept b sub 0, which is my y-intercept, equals intercept, and then again I have to select the y value first, then type comma, and then select my value of the x, 2.7592. That's how you can find the slope and the y-intercept in Excel. Remember, the commands will be equals intercept for the y-intercept and equals slope for the slope. Now, for the last part of this video, I would like to show you how to do the same in Desmos. Feel free to also use Desmos for your graphing, as a graphing tool and as a least squares regression line creator tool. I'm going to first start by sending my data or typing my data into Desmos. I'm going to create a table with these order pair values. You Google Desmos.com if you have never visited Desmos, and you can click on the first option or go straight into the graphing calculator. If you click just on the website, then you have to click here on this button for opening the graphing calculator. I know mine is in Spanish, it's because my computer is set up in Spanish. Or you can click on the first option of this icons, graphing calculator. Then you're going to create a table. You're going to click here on the plus symbol, and you're going to input all of your values. I'm going to click on plus, table, and then put all of my values there. Here I already have all my values inserted. If you want to, you can even see the graph of those points. You can always change the range. If you click here, you can change the range of the x-axis and the range of the y-axis if you want to see it in a different form. But this is how my data looks like. My regression line, I can find by setting up this command. That's a regression line. That's a regression line for this data. How do I set up this command right here? Well, let me close it. You're going to tell the computer that you're going to be using these two columns of data, y sub 1 and x sub 1. To put that superscript, you can click here on the keyboard, click on ABC, and it will be this button right here. Let's try it. I'll type y, and then hit this button, y sub 1. There you go. It's telling me that I have a list of 12 elements. Then we cannot set it equal to, because the least squares regression line, it's approximating your data set. It's not exactly aligned with your data values. So I'm going to be using this symbol right here to say I want you to create an approximation, a line that approximates this. Now, we have our values set up as b sub 0 and b sub 1 for b sub 0 for the y-intercept and b sub 1 for the slope. You don't have to use those letters. You can change the letters to A and B if you want to, or M and N. It's up to you. To keep it the same, I will be using b sub 0, b sub 1. I want my equation to be of the form b sub 0, this button again, plus b sub 1, b sub 1 times x. Oh, make sure that you exit first. Times x. Now, nothing happened. Why not? Because you have to tell the graph that you want this column to be your input variables or your explanatory variables. So I'm going to click here again. X sub 1 represents those values. And Desmos will compute everything for you. It will compute the correlation coefficient, which is right here. It will compute your y-intercept, which is b sub 0. And it will compute your slope, which is b sub 1. This is another tool you can have and you can use for finding your linear regression. Once you get your equation, Desmos will graph it for you. But in the case you're using Excel, you will have to manually type it like this in Desmos, and it will still record the graph. Now we can predict for any price of milk using the price of eggs. So for example, for the price, whenever the price of eggs is 1.91, the price of milk is going to be 3.52, and so on. You can keep on practicing using this graph. Now, we want to be able to find the difference on the price of milk given the prices of the eggs difference. You don't have to. Remember that last slide that I had you multiplying, let me go back, that I had you multiplying the difference from the price on eggs to predict the difference of the prices of the milk? You don't have to. If you're being asked to do this and you don't want to actually multiply the difference times the slope, or you forget how to do so, just go here and find the difference for the price of milk given the price of the eggs, both of them. You just find whatever the prices are and then subtract them. Thank you so much for watching this video. I hope it was very helpful, and I hope that it clarifies a few questions you might have when you saw the slide presentation. Have a very good day.